MR of cyclohexene is 82. MR of cyclopentane is 70. MR of ethene is equal to 28. MR of pentane is equal to 72. So first let's find out the number of moles. N is equal to mass over mR. So 1 divided by 82, the number of moles are 0. Let's find out the number of moles. 1 divided by 82. So the number of moles are 0.012. So cyclopropene 1 divided by 70, the number of moles would be 1 divided by 70. The number of mole is equal to 0.014. Next, ethene 1 divided by 28, the number of mole would be 1 divided by 28 is equal to 0.0357, and 1 divided by 72, the number of mole would be 1 divided by 72 is equal to 0.0138. So if we find out the number of moles of carbon dioxide, 3.22 divided by 44, number of mole would be equal to 3.22 divided by 44. The number of mole would be equal to 0.073. 0.073. So let's calculate the C6H12 plus oxygen to form carbon dioxide. This is A. CO2 plus H2O. So just to balance the reaction, just write on C6H10. Cyclohexane would be C6H10. 5H2O and 6CO2. 6CO2, 5 to the 10, and now 6 to the 12 or 5, 17, 8.5. So now 0.072. So this is 0.012. So 1:6 and 0.012 ratio X. 0.012 into 6 is equal to 0.012 1 divided by 82 is equal to 0.1219. So 0.01219 into 6 is equal to 0.13. 0.0121 122 into 6. This is equal to 0.073. So this must be correct. So you will find out like this for all other compounds, cyclopentane, ethene and pentane, by following this method. So this must be correct, which because mole of carbon dioxide from the chemical equation by solving 1 gram of Q is equal to 0.073. So cyclohexane must be correct. Now next question is, originally chemists thought indium oxide had the formula indium INO. By experiment they showed that 4.8 gram of indium combined with 1 gram of oxygen to produce 5.8 gram indium oxide. The AR of oxygen was known to be 16, which value of for the AR of indium is calculated using these data. So we know we can find out by using the empirical formula, by using that we have 4.8 grams indium and 1 gram oxygen to produce 5.8 gram indium oxide. 5.IN plus O2 to form INO. 2IN. So the same 4.8 and 1.0 gram. So this is equal to 5.8 gram. We can find out 5.8 gram indium oxide. Oxygen mass of 4.8 and 1.0 by using mass over AR divided by 16 and divided by X. We can simply find out by using this cross multiply 4.8 into 16 is equal to 4.8 into 16 divided by 1. This is equal to 76.8. So this is equal to 76.8, which is approximately 77. So answer would be B. Question number 5. In which substance are the only intermolecular forces temporary dipole induced dipole attraction? Hydrogen chloride, there is strong electronegative difference, partial negative, partial positive. This is polar. So over here permanent dipole forces are present. Polar molecules, methanol, CH3OH. So this is again polar due to the presence of electronegative element oxygen, C8 H8. So this is non-polar molecule because there is no difference between the slight difference between the electronegativity values. So this is non-polar, and non-polar molecules exhibit dipole induced ID forces, induced dipole induced. So this must be correct. And water also is a polar molecule, so this is also incorrect. Next question is, a solution contains 0.25 grams sulfur dioxide in 1 dm cube of water. Which volume of sulfur dioxide measured at 50 degrees centigrade and pressure 1 into 10 raised power to 5 Pascal must be added to 1 dm cube of water to produce this solution? So we have 1 dm cube of water, 0.25 grams sulfur dioxide. So first calculate the number of moles. N is equal to 0.25 divided by 64, which is equal to 0.0039. Then we have formula, which volume of sulfur dioxide measured at 50 degrees centigrade. So volume of sulfur dioxide we have to calculate. PV is equal to nRT and V is equal to nRT over V, where N is the number of moles, 0.0039, 0.0039 into R is the gas constant, 8.31 from the data booklet, 323. 50 degrees centigrade is a temperature, so when we add 273, so we get 350 degrees centigrade temperature, 273, 3, 2 and 3. So 323 is the temperature in Kelvin, is equal to 1 into 10 raised power to 5. So this is equal to 0.000105 meter cube, and volume over here in centimeter cube, so we can, here it is in meter cube, so it is 0.00105 into 10 raised power to 6 is equal to 105 centimeter cube. So D must be correct. So next question. So we will solve over here. An experiment was performed to determine the enthalpy of combustion of ethanol. The data collected are shown. Mass is W gram, mass of ethanol is burned is equal to X gram, temperature rise Y, molar mass Z, 4.2 specific heat capacity. Which expression can be used to calculate the enthalpy of combustion of ethanol in kilojoule mole inverse 1? So we know that Q is equal to mc delta T, and delta H is equal to, because reaction is exothermic, this is enthalpy change of combustion, so it is equal to negative, it is exothermic reaction. mc delta T divided by 1000 into N kilojoule per mole. So we can use these values, W into 4.2 heat capacity, specific heat capacity 4.2 into temperature is Y divided by 1000 into mole. Mole is equal to mass over AR. So mass of ethanol is X divided by MR, molar mass of ethanol is Z. So this is Z. So this expression can be written like this: W into 4.2 Y Z divided by 1000 into X. So let's check this expression, and this is minus. Which expression can be used to calculate the enthalpy change of combustion of ethanol in kilojoule mole inverse 1? So A is 4.2 WYZ, W into 4.2 YZ. Yes, this is correct. And 1000 into X, 1000X is also correct. So this must be correct. VO2Cl react with sodium iodide under acidic conditions. React with sulfuric acid and sodium iodide to form VOCl2, VOSO4 plus I2 plus Na2SO4 plus 2H2. The oxidation state of chlorine is -1 and -1 over here and over here. Which row about this reaction is correct? So VO2Cl, within VO2Cl, the oxidation state is V minus oxygen 4 minus 1 is equal to 0, V is equal to plus 5. Similarly, VOCl2, V minus 2 minus 2 is equal to 0. So V minus 4 is equal to 0, V is equal to 4. VOSO4 is equal to 0, V minus 2, SO4 whole minus 2, so taking 0, V minus 4 is equal to 0, V is equal to 4. So vanadium and iodine is 0 and vanadium over here plus 4, over here plus 5, over here plus 5 and over here plus 5. Okay, so sorry, over here plus 4 and 4. So vanadium and iodine over here -1, iodine is -1 to oxidized and vanadium is reduced, +5 to +4. So is oxidized, wrong, this is correct. Is oxidized, is reduced, vanadium is reduced and it is oxidized, so this must be correct. In which reaction is water behaving as Bronsted-Lowry base? Bronsted-Lowry base is the proton acceptor. Okay, water plus sodium, this is over here sodium act as a, because it is a metal, act as a base, water act as an acid, so it forms sodium hydroxide half H2, water H3PO4, hydronium ion and H2PO4. Over here H3PO4 act as an acid and it act as a base, so water accept proton. So in which reaction the In which reaction is water behaving as Bronsted-Lowry base? The base is proton acceptor. Over here in this reaction, water accept proton from the H3PO4, so it must be correct. So over here, calcium oxide is a base and water act as an acid. Over here, ammonia and copper, so this is water 5 OH negative. Ammonia act as a base because ammonia accept proton. This must be incorrect, so B is correct option. A large excess of marble chips is reacted with 25 centimeter cube of 1 mole per dm cube hydrochloric acid at 40 degrees centigrade. How is the result different when the reaction is repeated? There are two experiments, experiment 1 and experiment 2. In both cases, large excess of marble chips is reacted. Over here at 40 degrees centigrade, over here at 40 degrees centigrade, but the concentration and volume is different. How is the result different when the reaction is repeated with this is experiment 2, 60 centimeter cube of 0.5 centimeters. So let's find out mole in both experiment 1. Experiment 1, 60 divided by 1000, volumes, concentration into volume 0.3. This is experiment. This is experiment 2. Now experiment 1, 25 divided by 1000 into 1 concentration. So let's calculate. 60 divided by 1000 into 0.5. This is equal to 0.03 mole, and 25 divided by 1000 is equal to 0.025. 0.025. The question is calcium carbonate plus HCl to form CaCl2, H2O and carbon dioxide. This is limiting and this is excess. So the reaction is faster and more of the products are made when the reaction is complete. How is the result different when the reaction is repeated? The reaction is fastest and more of the products are made when the reaction is complete. More of the reactants are made. Reaction is slowest because 0.5 concentration is reduced when the reaction is complete, 0.03. So this is correct. The reaction is faster and less the products are made when the reaction is incomplete. The reaction is slower, yes, this is correct, and more of the products, yes, more of the products are made from the when the reaction is complete from the as compared to experiment 1. So this must be correct. The reaction is slower, this is correct, and less the products, this is wrong. So C option is correct. Question number 11. The Boltzmann distribution curve for a gaseous mixture of ethene and hydrogen is shown. Nickel is an effective catalyst for the reaction that occurs. Okay, how does the diagram appears if the same reaction mixture is at a higher temperature? So we know that temperature does not depend it does not affect the catalyzed or uncatalyzed reaction. So it means if the temperature is changed, this must be like this. So there is no change in catalyzed and uncatalyzed reaction. How does the diagram appears? If the same reaction mixture is at higher temperature, the curve is unchanged. The curve is unchanged. Curve is changed, so this is incorrect. The value of both EA and EA decreases, so this is also incorrect because temperature does not affect the catalyzed or uncatalyzed reaction. The value of both EA and EA, catalyzed activation energy of catalyzed and activation energy increases, so this is also incorrect. The value of both EA remains the same, catalyzed and EA remains the same, so this must be correct. D is correct. Which observations are made when sample of silicon chloride is added to a beaker of water? Let's see. SiCl4 when react with water to form SiO2 plus HCl is formed. 4HCl is formed. So no visible change is observed. So there is visible change because silica is precipitates are formed. Steamy fumes and precipitate are both observed. Yes, HCl is the steamy fumes. So this must be correct. And precipitate are both observed. Silica, solid silica is produced. So this must be correct. Appearance of precipitate is the only observation. So this is also incorrect. The appearance of steamy fume is the only. So this is also incorrect. Which row is correct? Which row is correct? The first ionization energy of phosphorus is greater than that of magnesium. Yes, this is correct. The electron is lost from a 3p orbital in both cases. So magnesium does not has p orbital. So this is incorrect. So A is incorrect. The melting point of phosphorus is greater than that of magnesium. Phosphorus is non-metal, magnesium is metal, so melting point, this is also incorrect because melting point of magnesium is more than phosphorus, greater than phosphorus. Phosphorus has more valence electrons than magnesium. Yes, this is correct. The atomic radius of phosphorus is smaller than that of magnesium. Atomic radius is going to decreases across the period, so it is correct. Phosphorus has greater nuclear charge than magnesium. This is also correct because phosphorus has greater nuclear charge than magnesium, more proton and electrons. So C must be correct. The electrical conductivity of phosphorus is smaller than that of magnesium. Phosphorus is non-conductor of electricity, so it is incorrect. Bonding changes from ionic in magnesium to covalent in phosphorus. Bonding changes from ionic in magnesium to covalent. This is correct, but this is also incorrect. Which row correctly describes one property of barium and one property of barium oxide? One property of barium and one property of barium oxide. Observation when barium metal is added to water. Barium react with water to form barium hydroxide, OH with bubbles of hydrogen gas, while barium oxide plus water, only barium hydroxide is formed. So observation: when barium metal is added to water, a few gas bubbles, so barium reactivity increases in group 2 down, reactivity of metals increases downward, so few bubbles, no enough bubbles are produced. This is incorrect. And the barium hydroxide 100 centimeter, barium hydroxide, because reactivity increases, so strong alkaline solution is formed, so 8 pH is incorrect. B, a few bubbles, this is also incorrect. 13 pH is correct because strong alkaline solution is formed. Rapid effervescence, because barium is strong metal, so rapid effervescence is formed. This is correct, but there is low pH, so this is incorrect. Rapid effervescence is seen and 13 pH. This is correct. This is correct. So D is correct option. And anhydrous white salt Z is heated strongly for 30 minutes. Z is heated strongly for 30 anhydrous, and a mixture of gases is given off. The solid remaining mixture of gases, solid remaining in the test tube, is then dissolved in small volume of dilute hydrochloric acid. The addition of few drops of dilute sulfuric acid test tube causes a white precipitate to form. Let's see, barium carbonate, only one gas is given off, so this is incorrect. Mixture of gases, barium, this barium nitrate and magnesium nitrate, two options can be. Barium nitrate gives mixture of gases BaO plus NO2 plus oxygen gas, 2NO2, 2 3s are 6, 2 2s are 4, 1 2. So this is balanced chemical reaction. Magnesium carbonate, again carbon dioxide is only one gas is given. Magnesium nitrate, also mixture of gases MgO plus NO2 plus O2 and 2NO2. So second, the acid addition of few drops of dilute sulfuric acid, HCl, when we add residue, this is residue and this is residue, when we add hydrochloric acid, in both cases soluble salt is formed, barium chloride and magnesium chloride. The addition of few drops of dilute sulfuric acid, but we add, let's see where we solve it, barium oxide. If we add barium oxide HCl to form BaCl2, barium chloride is formed plus water. This is aqueous salt. And when we add few drops of sulfuric acid in this mixture, in this solution, barium sulfate, white precipitate of barium sulfate is formed. So B must be correct, because when we add magnesium chloride and magnesium sulfate are soluble salt, when we add magnesium hydrochloric acid and magnesium oxide, magnesium chloride is formed, MgO plus HCl to form MgCl2. This is aqueous salt. And when we add magnesium sulfuric acid, again aqueous magnesium sulfate is formed. So this is incorrect, plus HCl. So this must be correct. This is incorrect, incorrect, incorrect. One gas and two gases, but just soluble salts are formed in all cases. Question number 16. Question number 16. Chlorine gas is reacted with aqueous sodium hydroxide. The oxidation number of chlorine changes from 0 to -1 and also from 0 to +1. So this is the reaction, Cl2 plus sodium hydroxide to form NaCl, 0 to +1 and 0 to -1, NaClO, over here +1, over here -1, plus water. Okay, under which condition does this reaction occur, and what is the color of the solid silver salt with chlorine in the oxidation state -1? So AgCl is the insoluble salt, white precipitate, color of white salt is formed. So reaction conditions, there are two conditions when chlorine react with sodium hydroxide. One would be the cold dilute alkali sodium hydroxide, and one would be the hot. So these two, cold alkali, yellow precipitate with iodide salt, so this is chloride salt, so white precipitate. So A must be correct option. So this is correct, but this is incorrect. Hot concentrated with NaClO3 and NaCl form, 0 to -1 and 0 to +5 oxidation state is formed, NaClO. Okay, this is also, this is correct, incorrect, this is incorrect, and this is correct, sorry. And hot concentrated alkali, incorrect, yellow also incorrect, so A must be correct. When concentrated sulfuric acid react with sodium iodide, NaI plus H2SO4 to form sulfur iodine plus hydrogen sulfide, H2S plus sulfur dioxide. So which statement is correct? Hydrogen sulfide is the product of reduction reaction. So let's see, H2S -2, oxidation state over here +6, so +6 to -2, so this is reduced, and +6 to +4, this is also reduced. Hydrogen sulfide is the product of the reduction reaction. This should be correct. Iodide ions are stronger oxidizing agent than sulfate ions. Iodide ion is stronger oxidizing agent than sulfate ions. So iodide ion is not a stronger oxidizing, iodide ion is a reducing agent. Are stronger oxidizing agent than sulfate ions. +4 -2 +4 and -1 to 0. Iodide ion is oxidized while sulfate is reduced, so sulfuric acid is oxidizing, so this is incorrect. Sulfur atoms from the sulfuric acid are both oxidized, and sulfur atoms, this is only reduced, -2 and +4. This is also incorrect. Sulfur atoms from the sulfuric acid are oxidized to make sulfur dioxide. Sulfur atom from the sulfuric acid are reduced to form sulfur dioxide. So this is also, so A is the correct answer. NO, NO2, CO and unburnt hydrocarbons are present in the exhaust gases of internal combustion engines. When catalytic converters are used to remove these compounds from the exhaust gases, redox reaction occurs. What happens to each compounds in the catalytic converter? Nitrogen monoxide is oxidized, carbon monoxide is also oxidized. Unburnt hydrocarbon is also oxidized in catalytic converter. So nitrogen monoxide is oxidized, this is correct. Nitrogen dioxide should be reduced, so this is incorrect. This is incorrect because carbon monoxide is oxidized, this is correct. Oxidized, reduced, no. Nitrogen monoxide is yes, loss of oxygen. NO2 nitrogen monoxide is can be oxidized as well as can be reduced. So nitrogen monoxide is reduced to form N2 plus, this is one of the chemical reaction in catalytic converter, NO plus oxygen to form NO2. So nitrogen monoxide must be reduced. So nitrogen dioxide is reduced, oxidized, carbon monoxide is oxidized, and unburnt hydro. This is correct option. Methylamine has similar chemical properties of ammonia. Methylamine reacts with hydrogen chloride to form a white crystalline salt, methylammonium chloride. A sample of methylammonium chloride is heated with aqueous sodium hydroxide. What are the products? CH3, NH3Cl plus NaOH. So NaCl plus sodium chloride and methylamine CH3NH2 plus water. So these are the products. So ammonia, sodium chloride and water, incorrect. Ammonia, sodium, hydrogen carbonate and sodium chloride, also incorrect. Methylamine, hydrogen chloride and water, also incorrect. Methylamine, sodium chloride and water, this is correct. So D option is correct. The structure of citric acid and isocitric acid are shown. How many chiral center does each? Chiral centers in which in organic compounds carbon must be surrounded by 4 different groups. So let's see. Carbon CH2 same. So this carbon to H2 not different group. So in citric acid there is no chiral carbon, 0 chiral carbon. Let's see. Carbon, hydrogen and hydrogen, so this is not C H. Look at this, CH2 CO2 H CH CO2 H, and over here C H OH and CO2H. So there are 2 chiral carbon. So this carbon is surrounded by 4 different groups, 1, 2, 3 and 4. And this carbon also has 2 different groups. So this must be chiral, this must be chiral. So in citric acid there is a 0 chiral, and D option is correct, because in isocitric acid 2 chiral carbon, so D option is correct.